Okay, so it says how many different options. So I don't want to see you do probability. You only do probability when you see what's the probability, then boom, your answer needs to be a fraction. What is the probability? Your answer needs to be a fraction. This says how many different ways. That's just going to be an answer. So let's start with the first one. So license plate has the following options. The first two must be letters, and the last four must be numbers, and by that I mean digits. Okay, you can use the same letters and same numbers. So there's 26 letters, and I can use the same letter, and I can use the same digits. So I'll just go 26 squared, and I get 676, and then I count 1, 2, 3, 4, 1, 2, 3, 4, and we'll say options. Whatever, just say something. This one is how many different types of sandwiches could she order? So we've got bread, cheese, and meat. Bread, cheese, meat. 4 times 3 is 12, times 6 is 72, different sandwiches. So that means if I wanted to, I could make it so I only every other month I repeat sandwiches. So it makes it feel like you have more variety when having maybe 6 different types of meat feels like every week you're going to have the same thing. All right, probability of picking an even number. So I'm going to highlight all my even numbers. I don't want to forget one. Even numbers are numbers that are divisible by 2, which means they end in 0, 2, 4, or 6. So 1, 2, 3, 4, 5, 6, 7, 8, 9 out of 10, 11, 12, 13. Double check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And we're good. I can't simplify. I'm not sure if I can simplify 9 divided by 13. Second PRB. I guess it's simplified. All right, I have 3 quarters in my pocket. 1 quarter, 2 quarters, 3 quarters. What's the probability that I have exactly 2 heads? Well, remember, if this was heads and this is heads, this one would have to be tails. So it's not as simple as an independent event. You're going to have to just list them. But I know that there's 2 options, heads, tails, 2 options, 2 options. So that means it's out of 8. So 2 heads. So let's see, H, H, T, T, H, T, and H, T, H. It looks like I got 3 options out of 8. Okay. So remember, because it's dependent, it's more complex. Because if you did 1/2 and then you took away that and made it 0 over 1, it doesn't make sense. All right, let's see. Frank wants to buy a puppy. We're only talking about puppies. So it's not the fundamental counting principle. Okay. And it says ways. It is not probability. So that means it's either going to be a 9. It's either a 9P5 or a 9C5. So let's see. All they want is puppies. So whether I pick the lab first, that's brown or white or black or a mix, it doesn't matter. The order doesn't matter. But if I was suddenly giving those 5 puppies names, now it matters. Because if the brown puppy's name is Bob or the black puppy's name is Bob, it's something different. So 9 factorial, 9 minus 5 factorial over 5 factorial. That's 5 factorial. 5 factorial is 9. 8, 7, 6. I don't need the 5. 5, 4, 3, 2, 1. 4, 3, 2. 4 times 2 is 8. 9 over 3 is 3. 3 times 7 is 21. Times 6. Oh my gosh, 126. I'm feeling like my brain isn't smart, so hold on. All right, we're good. 126 ways. All right, let's see. We got 10 students. All we're talking about are students, and there's a relay. So the relay matters because if you're picked first versus fourth, it does matter. So that would be permutation, 10, 4, 10 factorial over 10 minus 4 factorial. Look at the difference between these two. This one, combination means the order doesn't matter, so you're dividing out more. This one, the order matters, which means your answer will be bigger. So 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. So now I'm just going to go 9 times 8 times 7, and then add a 0, 5, 0, 4, 0 ways. Okay, let's go to the next page. All right, we got a green cube and a blue cube. So there's my green cube and my blue cube. What is the probability? So it means it's going to be not a fraction, or not 1 over, but a fraction. That the sum of the two numbers, that the sum of the two numbers has, that the two numbers has a sum of 7. Okay. So if I'm trying to get a sum of 7, if this is a 1, this is a 6. If this is a 2, this is a 5. If this is a 3, this is a 4. If this is a 4, this is a 3. If this is a 5, this is a 2. If this is a 6, this is a 1. But that would mean that all 6 numbers work. And we know you can't get a sum 100% of the time, because sometimes you could roll a 1 and get a 3. So that wouldn't work. So it's not as simple as this, okay? Which means what you're going to want to do is list them. And actually, I have that listed here. There is 1, 2, 3, 4, 5, 6 different ways that I could get a sum of 7. Out of how many? 36. And 6 over 36 is 1/6. Let me say it again. If I would have just listed these 6 out of 6 and 6 out of 6, that would have mean 100% of the time it will work. But I could get a 2 here and a 2 here. And if I add 2 plus 2, it won't work. So it doesn't work 100% of the time. So it's more complex. And I need to list all the possibilities, just like I did on the previous page with the heads and tails. Okay. All right. Through 6 different names in a hat, what's the probability, fraction, that each person picks their name out of a hat? So 1, 2, 3, 4, 5, 6. This is person A, person B, person C, E, and F. So let's just say that's their names. So what's the probability that person A will pick their name? There's a 1 out of 6 shot, because you either pick it or you don't. So once person A picks their pick, there's only 5 left. That means now B has a 1 in 5 shot. And now after B picks, there's only 4 letters left, and so on and so forth. So it's 1 over 30, 120, 360, 720. A 1 out of 720 chance that it's going to happen. Okay, probability. Up, there's that word even again. Probability that I have an even number. 2 is even, 4 is even, and 6 is even. 4 plus 11 is 15, plus 15 is 30. Let's see. 21, 29, 39, 40, 52, 55, 65, 70, 3/7. Of course, check it with a calculator and make sure I know how to add. All right, just simplifying, I can do that. So 5 factorial over 5 minus 2 factorial, 2 factorial. This means 3 factorial, which is 5 times 4, 3, 2, 1, over 2, 10. Now this one, you can cross, so this is 9, 8, 7, 6, 5, 4, 3, 2, 1. That one's out. And then that's 3 times 2. And now 3 times 4 is 12, times 7 is 84. So that's a good review of the quiz, but I encourage you to look at other problems and don't just define it by just these.